Here we'll talk about how to combine angles. But first, take a look at this angle over here. Which of these choices are correct names for this angle? If you're not sure, click down here to review naming angles. Right, you can call this angle GEF or FEG. Next, what's the approximate measure of this angle? To review, click down here instead. Nicely done. So it turns out this angle is exactly 60 degrees. Let's draw a ray that also starts at point E and goes through a point H. And suppose this new angle, HEG, measures 50 degrees. See if you can use this information to find the exact measure of angle HEF, which is this angle here. Excellent! You added these two angles together. So the measure of angle HEF is 50 degrees plus 60 degrees, or 110 degrees. In general, when you have two angles next to each other like these two, with a ray that's shared between the angles, you can find the measure of their combined angle by adding their measures together. Next, let's try a problem where you have to work backwards. In this diagram here, suppose angle BAD measures 180 degrees, meaning this is a straight line here. And let's say angle BAC measures 40 degrees. Try using this information to find the measure of angle CAD. Again, nicely done. In this case, you took the combined angle, 180 degrees, and subtracted the measure of angle BAC, which is 40 degrees. And so the measure of angle CAD is 140 degrees. So by adding and subtracting the measures of angles that are next to each other, you can often find the measures of other angles. So for your final challenge, take a look at these angles over here. Suppose the measure of angle FEG is x minus 10 degrees, so that's this angle over here. X is some number and you don't yet know its value. And suppose the measure of angle GEH is x plus 30 degrees, so that's this angle. And now suppose that angle FEH is 120 degrees, so that's this entire angle here. Try using this information to solve for the variable x. Nicely done. So you found that x equals 50 degrees. Let's make sure that's right. That means this angle here, x minus 10 degrees, is 40 degrees. And this angle here, x plus 30 degrees, is 80 degrees. And sure enough, the measure of angle FEH is 40 plus 80, or 120 degrees, like it says over here. So everything checks out, and 50 degrees is the correct answer. Suppose you have a right, or 90-degree, angle. Let's draw in another ray, and suppose this angle over here measures 60 degrees. What's the measure of this angle over here? If you're not sure, click down here to review. Right, this angle is 90 degrees minus 60 degrees, or 30 degrees. Now angles that add up to 90 degrees are called complementary angles. So these two angles are complementary. In other words, the complement of 60 degrees is 30 degrees, and the complement of 30 degrees is 60 degrees, because together these two angles add up to 90 degrees. So next, try finding the complements of angles measuring 80 degrees, 23 degrees, and 45 degrees. Nicely done. An 80-degree angle is complementary to a 10-degree angle, 23 degrees is complementary to a 67-degree angle, and a 45-degree angle is complementary to another 45-degree angle. So this is the definition for complementary angles. Next, let's draw in a straight line, which has an angle of 180 degrees. And let's draw in another ray, and suppose this angle over here measures 40 degrees. What's the measure of this angle over here? Right, this angle is 180 degrees minus 40 degrees, or 140 degrees. Now angles that add up to 180 degrees are called supplementary angles. So these two angles, 40 degrees and 140 degrees, are supplements to each other because they add up to 180 degrees. So your next challenge is to find the supplements of angles measuring 70 degrees, 90 degrees, and 154 degrees. Excellent! A 70-degree angle is supplementary to a 110-degree angle. The supplement of 90 degrees is actually also 90 degrees, and a 154-degree angle is supplementary to a 26-degree angle. So this is the definition for supplementary angles. Now here's your final challenge. Suppose I tell you that two complementary angles have measures of 2x and 3x. Try using this information to solve for the variable x. If you get stuck, click down here. Excellent! So x equals 18 degrees. Let's make sure that's correct. If x is 18, then 2x is 36 degrees and 3x is 54 degrees. So here's a 36-degree angle and here's a 54-degree angle. Sure enough, these two angles are complementary and add up to a 90-degree or right angle. So 18 degrees was indeed the correct answer. Let's introduce coterminal angles. But first, do you remember how many degrees are in a complete rotation, like this one here? If not, click down here to review. Exactly, there are 360 degrees in a full rotation. Now there's no rule that says 360 degrees is the most you can rotate. So let's take this line and rotate it just a little more than 360 degrees. So we've rotated this line by 370 degrees. If you didn't actually see the rotation, you'd say that it looks like the line rotated by a much smaller angle, this angle over here. So which smaller angle does a 370-degree rotation look like? Nicely done. You took 370 degrees and subtracted 360 degrees, the angle of a complete rotation, and got an answer of 10 degrees. These two angles, 370 degrees and 10 degrees, are called coterminal angles, which is the name given to angles that differ by a whole number of complete rotations. Let's look at another example. Let's rotate this line by 450 degrees. What smaller angle do you think is coterminal with 450 degrees? Precisely. So 450 degrees and 90 degrees are coterminal. Now for a trickier question. Which three smaller angles are coterminal with 1200 degrees? Here's a hint. You can keep subtracting 360 degrees to find more coterminal angles. Well done! You subtracted 360 degrees to get 840, and then another 360 to get 480, and finally another 360 to get 120. All of these angles are coterminal with 1200 degrees. Coterminal angles show up a lot in sports, like snowboarding. Perhaps you've heard of snowboarding tricks like the switch frontside 1080 double cork or the double McTwist 1260. So now you know what the 1080 and 1260 mean in these names. It's how many degrees you rotate while you're in the air. Now 1080 degrees equals 3 times 360 degrees. So a trick with a 1080 means you're making 3 full rotations in the air. And 1260 degrees equals 3.5 times 360. So a trick with a 1260 means you're making 3.5 rotations in the air. That last half rotation, or 180 degrees, means that if you started by facing one direction when you're taking off in the air, you're facing the opposite direction when you land.